Hi, welcome to the second video on aids in sketching a locus. So last time we've done talking with domain and range of a locus. So this time we'll be talking the other criteria in order for us to sketch the graph of a locus easily. So we'll be talking first with the intercepts. So intercept is when a point at which it intersects on the either the x-axis or the y-axis. So therefore, we have two intercepts, the x-intercept and the y-intercept. So when we say x-intercept, it's when the value of y becomes 0. So that means the graph of a locus intersect on the x-axis. Y-intercept is when the graph of a locus intersect on the y-axis. So let's say, for example, you have the sketch of a locus here. So these are the x-intercepts. And this is the y-intercept. That's it. So in order for us to solve for the intercept, we will assume, let's say for example, we will be solving for x-intercept, so we will assume y becomes 0, because at this value, y becomes 0. And for the y-intercept, we will assume x becomes 0, because at this value, x becomes 0. So example, we have 3x squared plus 2y minus 27 equals 0. So to solve for x-intercept, we will assume y becomes 0. So assuming y becomes 0, we have 3x squared equals 27. So x squared equals 9, which implies our x equals plus or minus square root of 9 or 3. So therefore, at point 3, 0 and negative 3, 0 is where the graph of a locus intersects on the x-axis. Now to solve for y-intercept, we will assume x equals 0. So that is 2y equals 27. So our y equals 27 over 2. So at this point, 0, 27 over 2 is where the graph intersect on the y-axis. That's okay. So the next criteria that we will be talking is the symmetries. So when we say symmetries, it's actually mirroring the graph. So let's say for example, let's write here first. So symmetries. So when we say symmetries, it's when the mirroring of graph with respect to a certain point. Example, we have a graph here. The graph of a parabola. Let's say, assuming my drawing is perfect, so this is parabola, center at 0, 0. So this implies that the graph is symmetric. So you have a graph here, and it's mirroring on the other side the same like this. So it's actually symmetric with respect to the vertical axis or the y-axis. So if you have a graph like this, so there is a reflection of this graph to the other side, then this graph is symmetric with respect to the x-axis. So if you have a graph like this, then that graph is symmetric with respect to the origin, because its reflection is along with the origin, and you get another graph the same with that, something like that. So on the illustration I have shown to you, there are three symmetries. So first is a graph symmetric with respect to the x-axis, and a graph symmetric with respect to the y-axis, and a graph symmetric with respect to the origin. So let's start with First, a graph is symmetric with respect to x-axis. So symmetric with respect to x-axis if and only if there exists an additive inverse of y. So if you have a point x, y on the original graph, so you should be able to find a point x negative y on the same graph. So a graph is symmetric with respect to y-axis if and only if there exists an additive inverse of the x. So this is different. When we say it's symmetric with respect to x-axis, you should be able to find the additive inverse of y. Now, if it's symmetric with respect to y-axis, then you should be able to find an additive inverse of x. Now, the third is it's symmetric with respect to the origin. It's when you will be able to find the additive inverse of x and the additive inverse of y. So, which means for the original graph, you have to replace, let's say for example, you're evaluating if that graph is symmetric with respect to x-axis. So, you have to evaluate the graph by replacing the value of y by negative y. Then you'll have to see if that resulting graph will be the same as the original graph. Example, I have a graph, let's say 4x squared minus y, or let's say x squared minus 4y minus 16 equals 0. So how will I be able to know if the graph is symmetric with respect to x-axis, to y-axis, or to the origin? All I have to do is to do this process. But first, let's check this. This is actually an equation of a parabola that opens upward. Okay, so let's check if this parabola is symmetric with respect to x-axis. So let's replace y by negative y. So x squared minus 4y minus y minus 16 equals 0. So you will get x squared plus 4y minus 16 equals 0. And this is not the original equation because the original equation is negative 4y. Here, this time is plus 4y. Therefore, this is not symmetric. Not symmetric with respect to x-axis. So, let's evaluate if it's symmetric with respect to y-axis. So, x squared. So, we will replace the x by negative x according to the rule. So, this negative x squared minus 4y minus 16 equals 0. Square root of negative x is x squared minus 4y minus 16 equals 0, and you will still get the same with the original one. Therefore, this is symmetric with respect to y-axis. Now, it's pretty obvious if this equation is symmetric with respect to the origin. Now, to the origin is when you will be able to find these both. The x and is when you will be able to find the additive inverse of x and additive inverse of y. Now, it's pretty obvious because you're done with checking with the additive inverse of y. Hence, this equation is not symmetric with respect to the origin. So, therefore, it's only symmetric with respect to the y-axis. And it's pretty obvious when you plot the graph of this equation. So, remember, this is a parabola that opens up. Why? Because if I reformat this into the standard equation of a parabola, so you may check on the video for the parabola. So you have 4y plus 4. So the vertex is at so the vertex is at 0, -4, and it's opens up, so something like that. So as you can see, this is symmetric with respect to the y-axis. That's it. Okay, so the next criteria that we will be talking is the asymptotes. So asymptotes is something, a graph at which it's approaches to but never touch on a certain region to where the asymptotic line lies. So let's say we have this line y equals m or x equals m. Okay, so this line, we call this line as the horizontal asymptote provided if the graph, the distance of this line and the graph itself approaches to 0 as the graph tends to either positive infinity or negative infinity. So this line x equals m is the vertical asymptote. So this is the horizontal asymptote, and the vertical asymptote is when the graph approaches to 0. I mean the distance of this line and this graph approaches to 0 as the graph tends to positive infinity or negative infinity. Okay, how do we do that? The technique in solving the equation of the line at which the graph is horizontal or vertical asymptotic to that is by solving x in terms of the other or y in terms of the other. Then we have to evaluate the resulting expression and check when the denominator gets 0. Okay, so to see that, well, let's consider an example here. 3x squared plus xy plus 4 equals 0. Okay, so to check for the horizontal and the vertical asymptote, so let's evaluate first. Let's solve for x in terms of y. Or let's, in this case, y is easier, so let's solve for y first in terms of x. So you'll have y equals negative 3x minus 4 over x. So the resulting expression is a rational expression. So the rational expression becomes, has a value of denominator of 0 when x equals 0. So therefore, this is the horizontal asymptote. I'm sorry, the vertical asymptote of the graph. So let's check first the horizontal asymptote. So let's solve for x in terms of y. So how do we solve this again in this expression? So we assume a equals 3, we assume b equals y, and we assume c equals 4. So we'll get x equals minus b plus or minus the square root of b squared, so which is y squared, minus 4ac, so 4ac all over 2a. Your a is 3. So you'll get negative y, Or even if I don't have to continue simplifying on this one, it's pretty obvious. You only have to check the denominator. In this case, the denominator is constant already, so no variable. So therefore, you will not be able to find a value on the real number system, I mean on the real number set at which this expression becomes zero. Therefore, this equation doesn't have a horizontal asymptote. That's it. Okay, so this time we'll be considering example at which we will be able to apply what we've learned about the symmetry, the intercept, and the asymptotes. So let's check on the example 1. So we have x squared minus 8y minus 32. So for number 1, let's check first the intercept. So for x-intercept, let's assume y equals 0. So therefore we have x squared equals 32. So x equals plus or minus the square root of 32, or this is equivalent as plus or minus 4 square root of 2. Hence, the x-intercept is the x-intercepts are 4 square root of 2, 0, and negative 4 square root of 2, 0. So let's check for the y-intercept. So let's assume x equals 0, so you'll get 8y equals negative 32. So you'll have y equals negative 4. Sorry. Times 2, 16 times, yes, 4. So therefore, your y-intercept is at the point 0, negative 4. That's it. So let's check for the symmetry. So let's check if it's symmetric with respect to the x-axis. So if it's symmetric with respect to the x-axis, let's replace y by negative y. So x squared minus 8 negative y minus 32 equals 0. You will get x squared plus 8y minus 32 equals 0. This is not the same as with the original equation. Therefore, this is not symmetric. So not symmetric with respect to x-axis. So let's check if it's symmetric with respect to y-axis. So let's replace x by x squared. So let's say minus x, let's replace x by negative x. So negative x squared minus 8y minus 32 equals 0. You will get x squared minus 8y minus 32 equals 0, which is the same as with the original equation rather. So therefore, this is symmetric with respect to y-axis. Since this is not symmetric to both x and y, therefore, this equation is not symmetric with respect to the origin. So, the only part at which it is symmetric to is for the y-axis only. So let's check for the asymptote, the horizontal and the vertical asymptote. So let's check for the horizontal asymptote. So solving for x, we have x squared equals 8y plus 32. You'll get x equals plus or minus square root of 8y plus 32. The denominator of this expression is 1, which is constant. Therefore, you don't have a variable on the denominator, so you will not be able to find the horizontal asymptote. Now, let's check for the vertical asymptote. 8y equals x squared minus 32. So, this is y equals x squared minus 32 over 8. So the denominator is still again constant, so you don't have a variable, so you will not be able to find a value in the real number system set at which the denominator becomes 0. Therefore, it doesn't have a vertical asymptote. So if you have question, you can comment down there. Okay, so this time we'll answer equation number 2. So for number 2, let's solve for the intercepts. So for x-intercept, let's replace y by 0. So this becomes 0 here. So you'll get 2x squared plus 1 equals 0. So you'll have 2x squared equals negative 1, which is now undefined because you cannot get the value. You cannot have a square root of negative something. Hence, it doesn't have an intercept. Okay. It doesn't have an x-intercept, rather. So let's solve for y-intercept. Let's replace x by 0. So you don't have y-intercept as well. Because if you replace x by 0, this becomes 0, this becomes 0. 1 is equal to 0 is undefined. Therefore, this equation doesn't have intercept. So let's solve for asymmetry. It's pretty obvious it doesn't have symmetry. Why? Because you will not be able to find the intercept. Therefore, it this graph of this locus doesn't meet the x-intercept. I mean the x-axis and the y-axis. So pretty sure you don't have the intercept. But to make sure, let's check. If I substitute this x by negative x, this is okay. It's still 2x squared, but this becomes negative. So therefore, it's not this is not symmetric with respect to y-axis. Now let's check. If I replace this y by negative y, this term changes. So therefore, it is not symmetric with respect to x-axis. So since this is not symmetric with respect to x-axis and y-axis, then this is not symmetric with respect to the origin. It's pretty simple. Now, let's check the asymptote. If I solve for y in terms of x, I shall be able to get 2x squared minus 2x squared minus 1 over 3x equals y. So at x equals 0, because this becomes 0 when x is 0, this is now the vertical asymptote. Now to solve for the horizontal asymptote, so let's solve for x in terms of the other variable. So my a here is 2, my b here is 3y, and my c is 1. So I have x equals minus 3y plus or minus square root of 9y squared minus 4ac over 2a. So the denominator is constant, so it doesn't have a variable. So there's no way for us to find a value on the real number set at which this expression has a denominator of 0. So therefore, it doesn't have a horizontal asymptote. That's it. Okay, so now here's another example. 3x squared minus x minus y equals 0. I'm not gonna solve on this one, but I want you to solve on this for me, so you can solve for the domain, the range, the intercepts, the symmetries, and the asymptotes. If you have questions or answers, perhaps you can comment down there. Okay, so we're done with the study of intercept, the asymptotes, and the symmetries in this video. So up next, we will be combining the domain, the range, the symmetries, the asymptotes, the intercepts, in order for us to sketch the locus easily. So thank you so much for watching, and if you have questions, you can comment down there. Or for those who haven't subscribed, subscribe now on the subscribe button below. Thank you. God bless.